Day 8. All right, we're taking a polynomial and we're dividing by a single term, so that's a monomial. This is a real simple process. You don't have to write this, but you can think of this as three separate fractions. 15x cubed over 5 minus 10x squared over 5 plus 5 over 5. And then you cancel each one separately. So 5 goes into 15 three times, and you end up with 3x squared. 5 goes into 10 twice, so you end up with a negative, that's a 3x cubed. And 5 goes into 10 twice, so you end up with 2x squared. And finally, these 5's cancel, so you have a plus 1. And that's all you need to do. You could have gone right from here to here, but by breaking it up into three separate fractions, you can physically cancel on each one without losing your place in each term. Okay, again, so I'm going to just write this as three separate fractions. You may not do this, but I'll do this so that I can more easily cancel. All right, when I do the first canceling, 3 goes into 9 three times. This y cancels with one of those, so I'm left with 3y. On the next one, 3 goes into 12 4 times, and the y's cancel as well, so I have plus 4. And finally, 3 goes into 15 5 times, so I'm going to be left with minus 5 over y, and that's all I can do. Okay, again, we're dividing by a single monomial, so I can write this as three separate fractions. And I can cancel these fractions separately. 5 goes into 15 three times. M squared cancels with two of those. These M squareds cancel. 5 goes into 25 5 times. 5 goes into 36 times. One of these m's cancels with one of those. Okay, so I'm going to end up in the first fraction with 3m. In the second one, I'll have plus 5. And the third one, I'll have plus 6 over m. And then we're done. Okay, again, this is a monomial, so I'm just going to write this as three separate fractions. You may be at the point where you are not bothering to do this, and you're jumping right to the answer, but I'm going to do this so I can see what I'm doing a little easier. Okay, in the first fraction, the 14's cancel, the m squareds cancel, this n cancels with one of those n's, so I'm left with just n minus. Okay, 7 goes into 14 twice, into 21 three times. This m cancels with one of those m's. This n cancels with one of these, making that a 2. So I'm going to be left with, let's see, a 3n squared over 2m plus. And finally, 14 goes into 28 two times. The m squareds cancel completely, and the n's cancel completely. So it looks like I'm left with plus 2, and that's it. And we're done. Okay, this problem we're dividing by a binomial, so it's a much more difficult problem. And before I do this, I want to just review how we're going to have to long divide, and I want to review how to do that. So we're going to set up a 9y plus 6, and we're going to put this into the top, which is y squared plus 3y minus 18. Now let's think about how we long divide. So if I had something like, say, 1, 2, 4, 7 divided by 5. The way I divide this out is I put the 5 into 1, 2, 4, 7. And then I'd say, okay, 5 goes into 12 two times. And then I'll take this 2 once I have it, and I'll multiply by this 5, and I'll get 10. And then I subtract, and I get 2. After I subtract, I'll drop down the 4. 5 goes into 24 4 times. Once we choose that 4, we multiply by the 5 and get 20. I'm running out of room here. And I subtract, and I get 4. Then I drop down the 7. 5 goes into 47 9 times. And 9 times this is 45. When I subtract, I get a 2. This 2 is a remainder, and the way I express my answer is 249 plus 2 over what I'm dividing by. Now, we don't normally, this is a number, and the way we write this is 249 and 2/5. Okay, so let's do that same thing here. To determine how many times this goes into this, all you have to do is look at this first term. And you ask yourself, what would you have to multiply 9y by in order to get to y squared? And the answer is y. Once you choose that, now we can take that y and we'll multiply. So y times 9y is 9y squared. 9 times 6y is a positive 6y. And now I'm ready to subtract. Once we start getting positives and negatives, it's very easy to make a mistake subtracting. So what I'm going to do instead, just as a rule, instead of subtracting, I'm going to flip the sign of the bottom row and I'm going to add. It's the same thing, but it'll save me once I get some negatives sprinkled in there. So 3y plus negative 6y is negative 3y. And just like over here, when we got this 2, the next thing we did is we dropped down the next item. So I'm going to do that here. I'll drop down the next item. Okay. I feel like I've written down the problem incorrectly because this is not coming out. Oh, it's not. It's because I did write the problem down wrong. Darn it. Okay, so here we have a binomial down here, and so we're going to have to long divide this. So I'm going to say y plus 6, and I'm going to long divide this into 3y, oops, what am I doing? Into y squared plus 3y minus 18. And just as a reminder on how to long divide, it may have been a while since you've done this. So let's say I did something like this, 123 over 5. The way you do this is you put the bottom into the top. And then you say, okay, 5 goes into 12 2 times. Once you choose that 2, you multiply by the 5 and you get 10. And then we subtract. 12 minus 10 is 2. When you're finished subtracting, you drop down the next item and you get a 3. And then you just repeat the process till you don't have any items left to drop down. So 5 goes into 23 4 times. 4 times 5 is 20, and we subtract and get 3. So this is 24 plus our remainder over our divisor. And we don't write numbers this way. We instead squish them together, but we wouldn't do that if those were polynomials. So that's that. So let's do the same thing here. In order to determine how many times this goes into that, you only need to look at the first term and ask yourself what you'd have to multiply this by to get to that, and the answer is y. Once you choose that, you just start multiplying. Y times y is y squared, and you distribute, so y times a positive 6 is a positive 6y. And then I subtract. Now, 3 minus 6y is a negative 3y. And then, now that I've subtracted, I drop my next item down. And again, to figure out how many times this goes into it, only look at the first term. Ask yourself what you'd have to multiply that by in order to get to negative 3y. And the answer is negative 3. Once you choose that, we multiply. Negative 3 times y is negative 3y. Negative 3 times 6 is a negative 18. These are identical, so after I subtract them, I get a 0 remainder. So I don't need to worry about a remainder like this. My answer is simply y plus 3. Now there's a much faster method of doing this that I'll teach you in just a little bit, but let's get the long division down first, and then I'll teach you a method. It's a little harder to learn, in fact a lot harder, but it's much quicker once you have learned it. It's called synthetic division. Okay, so here we're going to put the bottom into the top, 3t plus 2, and we'll put this into 3t squared plus 17t plus 10. All right, now I'm going to choose, I only look at these first items, and I have to multiply this by a t, and when I do that, I'll get 3t squared plus 2t. And now I'm going to subtract. I subtract and I get 15t. Now that I'm done subtracting, I drop down my plus 10. Again, remember, only look at the first item to figure out what you need to put up top. And it's a positive 5. Positive 5 times 3t is 15t. Positive 5 times 2 is a positive 10. And we subtract and get a 0. So I do not have a remainder. So my answer is t plus 5. By the way, you can always check if these two things divide to give you this, then you can re-multiply to give you this. And if you foiled this, if you were checking your work on a test, you could foil this and just make sure that it equals this when you're done, just to double check that you did everything correctly if you have the time. Okay, here I'm going to divide the bottom. P plus 6 goes into the top, and I'm going to put p squared plus 2p plus 20. I'm only looking at my first terms, and I have to use a p there so that when I multiply, I get to p squared. And I have times 6 is a positive 6p. And now I'm ready to subtract. 2 minus 6 is negative 4p. And then I drop my 20. So now, when I'm looking at just the first terms, I have a negative 4 that I put here. Negative 4 times p is a negative 4p. Negative 4 times 6 is a negative 24. Now, it's really easy to make a careless mistake when you're subtracting and what you're subtracting is a negative. That's confusing. So instead of subtracting in this case, I'm going to flip the sign of the bottom row and I'm going to add. And that'll prevent me from making a weird mistake. So I flip that sign and I subtract and I add, and I get a 44. So my answer is p minus 4. Now this is a positive and my remainder needs a sign. So I need to put a plus there. Don't just scrunch it next to the number like when we did when we were reviewing how to long divide. Now I put a fraction. The remainder goes on top of the fraction, and what you're dividing by goes on the bottom of the fraction. Remember, because this was a positive, I put a plus here. If that were a negative, I would still have a positive number up here, but I would put a negative out in front. And there's my answer. Okay, here we're dividing polynomials. So again, I'm going to put the bottom, which is what's after the divide, 2z minus 5 into the top. So I have 2z cubed minus 5z squared minus 6z minus 15. Okay, again, I'm only considering the first term, and I'd have to multiply this by a z squared. Now that I've chosen that, I start multiplying. Z squared times this is a 2z cubed. Z squared times this is a negative 5z squared. These lines are identical, so when I subtract, I get 0. I know I'm going to get 0 without even bothering to subtract. Then I drop the next item down, and I'll get negative 6z. Well, I need something to continue to divide by, so I'm going to drop a second item down all at one time, negative 15. Again, I'm only looking at the first item, and I'd have to multiply it by a -3. -3 times that is a -6z. -3 times a -5 is a +15. Well, be careful, because a lot of times people might think that they're going to subtract and get a 0, but you're not. Remember, because there's some negatives involved, we're going to flip the sign of the bottom row and add. That's the same thing as subtracting, but that'll give us a -30 as a remainder. So our answer, I'll write it here on the side, is going to be z, I'll do it in another color, is going to be z minus 3, and I'll put the minus out front, and I'll put a fraction, and I'll +30 over 2z minus 5. Now, some people will put a plus there and the negative on top of the fraction, but that's using more signs than is absolutely necessary, so you don't need to do that. You can put the negative out there and always put a positive up there. Okay? Okay, so again, I'm going to put the bottom into the top, so we have 2z minus 5 into 2z cubed minus 5z squared plus 6z minus 15. And I'm only looking at the first term. I have to multiply that by a z squared. And when I distribute, I get 2z cubed minus 5z squared. This adds up to 0 because they're identical, or subtracts a 0. And then I drop this plus 6z, and I'm going to drop a second one at the same time because I need two terms down there. Now I'll choose, I'm only looking at the first term, I have to choose a +3. 3 times that is a 6z, 3 times -5 is a -15. Those are again identical, so when I subtract, I'll get 0. So my final answer is z plus 3. All right, so I'm going to put the bottom into the top. All right, and again, I'll look at just the first term, this here and this here, and I need to multiply by x squared. And then I'm going to distribute over here. So I get 4x cubed plus x squared. Everything's positive, so I don't need to flip any signs. I can just subtract. 9 minus 1 is 8, and then I drop the 10. Again, I only look at the first term when deciding what to put up top, and it's a +2x. So now I can multiply, and I get 8x squared plus 2x. That's easy enough to subtract without flipping any signs. -10 minus 2 is a -12. Oops, sorry. That's just x. Okay. Is a 12x. All right. And then I drop the 3. Again, I just look at only the first term, and I need to put a -3 here. And when I distribute, I get -12x minus 3. And I'm going to flip the sign of the bottom row and add instead of subtracting so I don't make a weird mistake. 3 plus 3 is 6. So my remainder is 6. The way I write my answer is x squared plus 2x minus 3. It's a +6, so I'll put a plus, and then my fraction. I'll put the remainder over what I'm dividing by. And that looks like my answer. Okay, I'm going to redo those problems that I just did, numbers 9 through 17, using synthetic division. Now, this is a lot more difficult to learn, but once you learn it, it's way easier. So let's start with the first one. Y squared plus 3y minus 18 over y plus 6. Now, I'm going to make a little box like this, and I'm going to put the opposite of this and this number divided by the coefficient here. So in other words, I'll put a -6 in. And then I'm going to list out my coefficients here. So in other words, I'll put a 1, a positive 3, and a negative 18. Okay. You start by dropping this item down. You get a 1. And then all you do is you multiply this negative 6 here times the 1 to get negative 6. And I put it up in the next spot there. And then I add this column up again. And I get negative 3. And then I take my negative 6 and I multiply it by negative 3. And I get a positive 18. And I add this column up and I get a 0. Since we started with x squared, this is my first coefficient, and it's always 1 power less than what I started with. So instead of y squared, it's a y. And then this is a minus 3. And that's my answer. That was a little bit complicated, but once you learn how to do this, it takes way less scratch work, and it'll be done much, much faster. Okay, so I'm going to start by putting a negative 2/3 in the box. Remember, this is the opposite of this, and this number divided by this number, as if you were setting this equal to 0 and solving. Okay? All right, so now I'm going to put my coefficients, 3, 17, and 10. I'll put a line like this, and you always start by just dropping that first item down. So now I multiply the number in the box by that. The 3's cancel and I get negative 2, and I just repeat this process. I add up this column and get 15, and I multiply the box by that. The 3 goes into the 15 5 times. 5 times 2 is negative 10. I add this column up and I get a 0. Now, these are not yet my coefficients. In this problem, we have a coefficient here of 3. On the last problem, we didn't. So you always have to divide these coefficients. Never divide the remainder. Just divide these coefficients by that. I didn't show it in the last step because the coefficient was 1, and dividing by 1 doesn't change anything. But once you divide that, now my coefficients are 1 and 5 with a remainder of 0. So this was a t squared, so this is now a t, that's a positive 5, so that's the answer with no remainder. I know that's confusing, but once you get the hang of this, these problems will go much faster for you. And you'll be much less likely to make a careless mistake. Okay, so I'm going to make my box. I'll put a negative 6 because it's opposite of this number over the 1. And then I'll list out my coefficients, 1, 2, and 20. I'll put a line and I'll start by dropping the 1 down. Now I multiply. Negative 6 times 1 is negative 6. I add this up and get negative 4. Negative 6 times negative 4 is a positive 24. I add this up and I get 44. That's my remainder. I don't need to divide these coefficients by anything because there's a 1 there. And if I divided it, I'd end up where I was at anyway. So this is a p squared. So this is going to be a p, 1 less exponent, minus 4. And we're done. Oops, I'm sorry, there's a remainder on this problem. So p minus 4 plus, because this is a positive, and it's 44 over p plus 6. And that's my final answer. Okay, so here I'll make my box here. I'm going to put in a positive 5 over 2. It's the opposite of this, and this over this. And now I'm going to list out my coefficients. So I have a 2, a negative 5, a 6, and a negative 15. I'll start by dropping down the 2. 5 halves times that. The 2's cancel. I get 5. This adds up to a 0. 5 halves times 0 is 0. This adds up to a 6. When I multiply this, 2 goes into 6 3 times. Times 5 is 15. I add up and get a 0. So I don't have a remainder here. These are not yet my coefficients because I did have a leading coefficient of 2. So I have to divide by 2. And my coefficients are actually 1, 0, 6 with a remainder of 0. This was to the third power, so this 1 is going to be to the second power. So I have t to the second power plus 0t plus 6 with no remainder. Okay, So again, I'm going to start with my box. I hope everybody can see that I'm going to put a negative 1/4 in my box there. And now I'm going to list out my coefficients, 4, 9, negative 10, and 3. I'll start by dropping the 4. Negative 1/4 times that is a negative 1. I'll add up this column to get 8. Negative 1/4 times that, 8 is negative 2. I'll add up this column and get negative 12. Negative 1/4 times negative 12 is a positive 3. I'll add up this column and get a 6. Remember, I'll put a box around that because I don't want to mess with that. But there is a leading coefficient of 4 here. So these are not yet my coefficients. I have to divide by 4. So my coefficients are actually 1, 2, negative 3, and 6 as a remainder. Remember, we don't mess with that. So my final answer, this is to the third power, so this is going to be to the second power. So I have, oops, not t, it's x. X to this, I'm going to have to squeeze this in kind of small. So x to the second plus 2x, I just keep dropping down 1x at a time, minus 3. This is a positive 6, so I put a plus, and now I put my fraction. I put the remainder on top of the fraction, and what I'm dividing by on the bottom of the fraction. And remember that when you do this, you need a sign before your remainder term. This was a positive 6, so I put a plus there. Oops. So I put a plus there. All right. All right, number 19. We're going to put the bottom into the top. There is a way to synthetically divide this, but it's a lot more work, and it's not worth the time and energy. We're just going to always long divide when we have 3 terms. Now, I have to put this in descending order. So I'm going to put my 6x cubed first, then my negative 19x squared, then the positive 14x, and finally the negative 15. All right. I'm only looking at the first term, and I have to multiply the 3 by a 2x to get to 6x cubed. Once we choose that, we multiply, and we get 6x cubed minus 6x squared, not 6, but 4. 2 times 2 is 4. 4x squared plus 8x. Now, we have a bunch of negatives, and subtracting negatives is confusing. It's easy to make a mistake. So I'm going to flip the sign of the bottom row and add rather than subtracting. And that's the same thing as subtracting. So I have negative 19 plus 4 is a negative 15x squared. 14 plus a negative 8 is a positive 6x. And then I drop down the negative 15. Now I'm only looking at the first term. I got to multiply the 3 by a negative 5 in order to get to 15x squared. So now I distribute. Negative 5 times this is negative 15x squared. Negative 5 times that is a positive 10x. Negative 5 times that is a negative 20. Again, because I have those negatives in the bottom row, I'm going to, instead of subtracting, I'll think about it as flipping the sign of the bottom row and adding. And so I end up with, the 15s go away, 6 plus negative 10 is a negative 4x, and negative 15 plus 20 is a positive 5. So that's there's nothing left to drop down, so that's my remainder. And I'm going to fit my answer right up here. Okay, so my answer is going to be 2x minus 5, and then I'm going to put a plus. I'll put negative 4x plus 5 in the numerator, and what I'm dividing by in the denominator. Remember, you need a sign in front of your remainder. It's easiest to make it a positive and put the remainder exactly the way you see it up in the numerator. The key thing to notice in this is that we're going from an x cubed down to an x to the 1. We're skipping the x squared. So whether you long divide it or synthetically divide it, we need to put in a placeholder of a 0x squared. So if we long divide it, we'll put x minus 2 here, and we'll put 3x cubed plus 0x squared. Then we have a minus x and a plus 4. Okay, when we put this in, we'll have 3x squared here, and then we'll multiply and get 3x cubed. And this times this is a negative 6x squared. If we did not have the 0x squared there, we'd have a negative x above it, and we'd be stuck because those would not be like terms. All right, because of the negative, instead of subtracting, I'm going to flip the sign, and then I'm going to add, which is the same thing. And I'll get 6x squared. And now I'll drop down the negative x. I'm only looking at the first term. I have to multiply x by a positive 6x to get to 6x squared. And now I distribute. 6x squared, 6x times negative 2 is a negative 12x. And again, because of the negatives, instead of adding or subtracting, I'm going to flip the signs of the bottom row and add. And I'll get 11x. And now I drop the 4. Now, looking at just the first term, I put a plus 11 here. And I'm going to multiply, and I get 11x minus 22. And because of the negative, I'm going to flip the sign of the bottom row and add instead of subtracting, and I'll get a 26. So I'm going to squeeze in my final answer here in the bottom left. My final answer is 3x squared plus 6x plus 11. It's a positive 26, so I put a plus, and I put 26 over x minus 2. Now, let's do that synthetically. If I did this synthetically, I would put a positive 2 in the box because it's the opposite of this over the coefficient. And then I'm going to list my coefficients. Remember, you need a 0. So I need a 3, a 0, a negative 1, a 4. I'm going to start by dropping the 3. 3 times 2 is 6. I add up this column and get 6. 2 times 6 is 12. I add up this column and get 11. 2 times 11 is 22. I add up this column and get 26. That's my remainder. I don't need to divide by anything because I did not have a coefficient. So this is my answer. This is 3x to the 1 less than what I started, squared, plus 6x plus 11, plus, because it's a positive, 26 over what I'm dividing by. That was a ton faster and a lot easier, and we get the same answer either way. All right, number 23. Okay, so we're going to do it long division first. I'll put x minus 5 here. Be careful because you're skipping one of the variables. So we have 2x cubed minus 11x squared. There's a plus 0x, then the plus 28. Okay, looking at just this first term, we multiply by 2x squared. And we're going to get 2x cubed minus 10x squared. Now that's confusing to subtract, so I'm going to flip the sign of the bottom row and add so I don't make a weird mistake. And I get negative 1x squared. Then I drop down the 0x. Okay, I'm going to multiply by a negative x. Put that in green. And when I multiply, I get negative x times x is negative x squared plus 5x. So when I subtract, 0 minus 5 is a negative 5x. You could have flipped the sign of the bottom row and added, it would have been the same thing. So now I have a plus 28. Finally, I put here a negative 5. And when I multiply, I get negative 5x. Negative 5 times negative 5 is a positive 25. Those are two positive numbers. That's easy to subtract without making a mistake. And we get 3. Okay, so my remainder is 3. So I'm going to squeeze my answer down here. Well, I'll do it over here. We got 2x squared minus x minus 5. That's a plus 3 over x minus 5. Okay, so that's the long division. Now, if I do this using synthetic division, it's a lot quicker and easier. I'm going to put a positive 5 in my box here. Remember, it's the opposite of this and that number divided by the coefficient. Then I'm going to put my coefficients down. I have a 2, a negative 11. Be careful, there's a 0 there, and then there's a 28. I'm going to start by dropping my 2 down. 5 times 2 is 10. This adds up to negative 1. 5 times negative 1 is negative 5. This adds up to negative 5. 5 times that is negative 25. This adds up to a 3. That's my remainder. I don't need to divide anything, so these are my coefficients. So it's 1 less than what you started. So 2x squared minus 1x minus 5 plus 3 over what you divided by. And again, you can see that you get the same answer, but the second method was much quicker and easier. Okay, now we're dividing by a trinomial. It looks like a binomial, but there's a missing k. So remember, you have to fill that in with a 0. So we have 2k squared plus 0k plus 1. And we're going to put this into 4k to the 4th plus 6k cubed. Now notice the k squared is missing, so I have to fill that in with a 0. Then I have plus 3k minus 1. Okay, so looking at just the first term, we'd have to multiply by a 2k squared. And once you choose that, you start multiplying. And you get 4k to the 4th plus 0k cubed plus 2k squared. That's a little difficult to subtract properly, so I'm going to instead flip the sign of the bottom row and add. And here I get 6k cubed. 0 plus negative 2 is a negative 2k squared. And now I drop the positive 3k. Now looking at just the first term, I'd have to multiply 2k squared by a positive 3k. And now I can start multiplying. I distribute to everything here, and I get 6k cubed plus 0k squared plus 3k, and I subtract. I'm going to flip the sign of the bottom row and add, and I'll get negative 2k squared plus 0k, and now I drop the last negative 1. Finally, I look at just the first term. It's a negative 1 that I'd have to multiply by. So I put that there and I start multiplying. I get negative 2k squared plus 0k. 1 times negative 1 is a negative 1. I subtract. Those are identical, so I have a remainder of 0. So my answer is right up above. I'm going to write it down again. Do not try to synthetically divide when you're dividing by a trinomial. There's a method of doing it. It's longer than the long division. It's very difficult. It's not worth it. So we'll always long divide when we're dividing by a trinomial. And this one didn't look like we were dividing by a trinomial at first, but we know we are once we put in that 0k. Okay, so I'm going to put the bottom into the top. I've got z squared minus z plus 2 into 9z to the 4th minus 13z cubed plus 23z minus 10z plus 8. All right, looking at just the first term, I'd have to multiply it by 9z squared to get there. So now I distribute, and I get 9z to the 4th minus 9z cubed plus 18z squared. And I'm ready to subtract with all those negatives. I don't want to make a mistake, so I'm going to flip the sign of the bottom row and add instead of subtracting. So I get negative 4z cubed plus 5z squared, and now I drop the next negative 10z. Okay, so now I only look at the first terms, and I have to multiply by a negative 4z to get there. And now I'm ready to multiply. Negative 4z times z squared is negative 4z cubed. I multiply and I get a positive 4z squared. And I multiply and I get a negative 8z. Again, with all those negatives, I think it's easy to make a mistake. So I don't want to subtract. I'm going to flip the sign of the bottom row and add. And I'll get 1z squared minus 2z, and finally I'll drop down that plus 8. Looking at just the first term, I have to multiply by a positive 1. And when I multiply 1, I get z squared minus z plus 2. And again, instead of subtracting, I'm going to flip the sign of the bottom row and add, and I'll get negative z plus 6. So that's my entire remainder since there's nothing left to drop down. So my final answer, I'll squeeze it right in here. I've got 9z squared minus 4z plus 1. And I'll always put a plus here. I'll put my remainder on top, z plus 6. What I'm dividing by on the bottom, z squared minus z plus 2. And that's my entire answer. Okay, so I have two functions. F of g is f divided by g. So this is simply 10x squared minus 2x over 2x. And we're dividing by a monomial, so I don't need to long divide. I can just break this up into two fractions. And I'll start canceling. 2 goes into 10 5 times. This x cancels with one of those. And I'm left with 5x for that term. And then everything cancels here. So I'm left with 1 over 1, which is just minus 1. So the division of those two functions is 5x minus 1. Okay, for number 35, we have those two functions. The division of those two functions is simply 2x squared minus x minus 3 all over x plus 1. And so I'm going to have to divide this out. You've learned two methods. I prefer synthetic division, so that's what I'll stick with here. I'm going to make a box. I'll put my negative 1 in there. And then I'll put 2, negative 1, negative 3. Those are my coefficients. I'll start by dropping the 2. So negative 1 times 2 is negative 2. This adds up to negative 3. Negative 1 times negative 3 is 3. This adds up to 0. There's no leading coefficient here, so I don't need to divide my coefficients by anything. So my answer is simply 2x minus 3 with no remainder. Okay, here we have f over g is 8x cubed minus 27 over 2x minus 3. So again, I'm going to use synthetic division. I'm going to put a positive 3 over 2. Hopefully you got that as the right number over the left number and the opposite sign. Okay, my coefficients, careful because I'm skipping x squared and x. So I have 8, 0x squared, 0x, then negative 27. So that's a little tricky. I'm going to start by dropping down the 8. When I multiply, 2 goes into 8 4 times. Times 3 is 12. This adds up to 12. 2 goes into 12 6 times. Times 3 is 18. This adds up to 18. 2 goes into 18 9 times. Times 3 is 27. So my remainder is 0. These are not my coefficients yet because we're dividing by the 2. So my coefficients are 9, or not 9, how did I get a 9? My coefficients are 4, 6, and 9 with a remainder of 0. So, okay, we started with x cubed. So this 4 is 1 less than that. So this is a 4x squared plus 6x plus 9. You just keep dropping your variable down, and there's no remainder. Okay, number 9, we're starting with those functions, and we're doing f over g. So we have x squared minus 9 over 2x. Again, this is dividing by a monomial, so you can break this up into two fractions, x squared over 2x minus 9 over 2x. Here we're going to cancel, so we're going to be left with x over 2 minus 9 over 2x. I'm not sure this answer was any better than the original as far as simplification, but that's what it's asking you to do. Okay, in the previous problem, we saw that f over g of x is x squared over 2 minus 9 over 2x. So x squared over 2 minus 9 over 2x, and now we're going to replace the 2 everywhere we see the x. So this is 2 squared over 2 minus 9 over 2 times 2, which is going to be 2 minus 9 over 4, which is 8 over 4, that's 2, minus 9 over 4. So we get negative 1 over 4. Okay, so h is x minus 3 over 2x. There's nothing wrong with leaving it just like this. So I'll do that this time. All right, in the previous problem, they had us find this. And now they're going to have us find h over g at 3, of 3. So let's plug in. Everywhere we see an x, we'll plug in a 3. So we have 3 minus 3 over 2 times 3, which is 0 over 6, which is 0. Page 368. All right, number 79, we have two functions. We're being asked to multiply those functions. So this is simply going to be 2x times 5x minus 1, and we simply distribute. And we get 10x squared minus 2x, and that's it. All right, again, we have two functions. We're multiplying them, so this is simply going to be the product of these two functions. And we can FOIL. Our first is 2x squared. Our outer is negative 3x. Our inner is a positive 2x. And our last is negative 3. These are like terms, and they combine, so we get negative 1x minus 3. And that's it. Okay, the product of these two functions will be like this. And remember, we're going to ignore the negative 3. We'll just start with the negative 2x, and we'll distribute that all the way through. Okay, so I get 8x cubed plus 12x squared plus 18x when I distribute that. Then I'm done with that, and I move on to the negative 3, and I distribute that through everything here. I get negative 12x squared, and I'll put that right here, minus 18x, I'll put that right there, minus 27. So notice that these columns add up to 0, and they're gone. So your final answer is 8x cubed minus 27. And that's it. Okay, number 85, fg of 2. I can multiply my two functions together first, and then evaluate them at 2. But that multiplication is probably more difficult than what I want to do. So what I can do instead is I can find what f of 2 is, I can find what g of 2 is, and I can multiply my two answers together, and that will give me the same exact result. So f of 2 is 2 squared, which is 4, minus 9. This is negative 5. G of 2 is 2 times 2, which is 4. So fg of 2 is the product of those, which is negative 5 times 4, which is negative 20. And that's a lot easier than doing the polynomial multiplication and then evaluating at that value. Okay, I can, instead of multiplying the functions together and getting a result and evaluating that result at negative 1, I can instead find f of negative 1 and h of negative 1 and find the results and multiply my results together. So f of negative 1 is negative 1 squared, which is positive 1, minus 9. So this is negative 8. H of negative 1 is negative 1 minus 3. So this is negative 4. So the product of these is negative 8 times negative 4, which is positive 32. Again, on this problem, I'm going to evaluate each of these functions at negative 2 and then multiply them together. Okay, f of negative 2 is negative 2 squared, which is positive 4, minus 9, which is negative 5. G of negative 2 is 2 times negative 2, which is negative 4. So this is negative 5 times negative 4, which is positive 20. Page 393. Okay, I'm looking for the greatest common factor. So when I look at 9, 3, and 15, 3 is the largest number that can go into all of those. When I look at the variables, to figure out what exponent to include on your variable, it's always going to be the smallest of all of them. So m. So 3m is the greatest factor that could be divided into all of these without a remainder. So that's the GCF. Okay, looking at the GCF, 8 is the largest number that can go into all three of those without a remainder. So here we have 8. When we look at the x's, this is to the 1, to the 2, to the 2. 1 is the least of those. And when we look at the y's, this is a 3, a 2, and a 1. 1 is the least of those. So this is the greatest common factor that can go into each of those without a remainder. All right, in this problem we have two different terms. In the first term we have three factors. Factors are items being used in multiplication. We have the 6, the m, and the r plus t. In the second term we have the 3, the p, and the r plus t. Okay, so let's look at the first things, the 6 and the 3. The greatest number that can go into both of those is a 3. This one has an m, this one doesn't. So we cannot include an m at all in our GCF. This one has a p and this one doesn't. In other words, the one on the left has 0 p's. So we have to go with the lower. So we cannot include any p's at all. This one has an r plus t to the second power. This one has to the fourth power. 2 is smaller, so that's what we're going to be able to include. So this will be r plus t to the second power, and that's the GCF. I think the instructions on this problem are really difficult to understand. But what this problem is trying to get you to see is that this could not be the answer because the GCF did not come out. In other words, there's a y here and a y here and a y here. So this one looks like it's completely factored, but when we multiply it in, 2 times 3 is 6. That works. But x to the third, this first term works. When we multiply by the second one, 2 times negative 6 is negative 12. X to the fifth works. y to the second works. When we multiply by the third one, 2 times 12 is 24. Y to the third times, x to the third times x is x to the fourth. Y to the second times y to the sixth is y to the eighth. So that one looks like it's going to work. I just want to make sure I didn't make a mistake there. Okay, and this last one, 6. Okay, this problem is really difficult to understand what they're asking you to do. This first one works because there's no common factor. We don't have a y in every term, we don't have an x in every term, and there's no number that's common to all three of these. And if we were to distribute this 6, we'd get right back to the original. So A is the answer, but let's look at why B, C, and D aren't going to work. In part B, you can see that right off the bat there's an x, an x, and an x. It has a common factor of x, so this has not been completely factored. Let's look at this part C. Here we have a 3, a 6, and a 12. 3 can go into each of those, so that hasn't been completely factored. And this last one, we have an x, and an x, so that hasn't been completely factored, so that's not it. But this part A does work. All right, number 9. We have a 10 is common to this and this, so if we factor out a 10, we'll be left with x, because 10 times x is 10x minus 3, because 10 times negative 3 is negative 30. So that's the answer. Some types of common mistakes would be something like this. Somebody might think, okay, those are both even, so I'll take out a 2. And that leaves a 15x, because 2 times, what am I doing, 15? 5x, because 2 times 5 is 10, minus 15, because 2 times 15 is 30. And while this has been partially factored, it cannot be our final answer, because 5 can go into both 5 and 15, and so we should have taken another 5 out. So this has not been completely factored. You need to have your answer completely factored so that nothing can come out of both of those items. All right. There's an 8 that can go into both of those. So if I factor out an 8, I'm left with s plus 2t. And you can double check. When you multiply and distribute, you'll get back to the original. And these items do not share a common factor. So this is our final answer. Okay, between the two of these things, 6 is the GCF. So if I pull out a 6, I'll be left with a 1 plus 2r. Okay, so 8 goes into both of them, and we can also pull out a k because there's a common factor of k common to both of them. So this is going to be a k squared, because 8k times k squared is 8k cubed plus 3. And you double check to see that if you would multiply it back, would you get back to this? And make sure that these do not share a common factor. And they don't, so that's our answer. All right, there's nothing in common between the 3 and the 5, but each of these have an x, and they both have at least one y. So we're going to pull out an x and a y, and that leaves behind a 3 from the first term minus a 5y from the second term. All right, I'm going to pull out a negative 2. I'm also going to pull out a p squared, because that's the smaller of those two. And I'm going to pull out a q to the 4, because that's the smaller of those two. That's going to leave behind a positive 2p for the first term plus q for the second term. And that's all you can do. Okay, it looks like 7 is the largest number that can go into all three of those. So I'll pull out a 7. And then I'm going to pull out an x cubed, because that's the smallest exponent of the x's. that leaves behind a 3x squared for the first term, a positive 5x for the second term, and a minus 2 for the third term. And that's all you can do. All right, 9 is the largest number that can go into those things. So I'm going to pull out a 9. And p to the second is the smallest of those. So I'll pull out a p to the second. And it's going to leave behind 4, because 9 times 4 is 36, p squared, plus 1 minus 3p. Okay, 5 is the largest number that can go into all of those, so I'll take out a 5. And then with the a's, I have a 2, a 1, and a 2, so 1 is the largest. For the c's, I have a 3, a 2, and a 1 here, so 1 is the smallest, so I can take out that. Now that leaves behind a 3ac squared for my first term, a negative 5c for my second term, and a plus a for my third term. Now, it's a good idea to double check that it multiplies back correctly and that you don't have anything common between all three things left behind there. And we don't, so that's my answer. All right, in this problem, there's nothing in common at all between my numbers. And this has an m, but there's no other m, so we can't pull out any m's. This has a p, but there's no other p, so we can't pull out a p. There's no other r's, there's no other s's, there's no other x's, there's no other z's. So there's nothing that's shared in common with all three of them. So this cannot be factored. And that's just the answer. All right, in a problem like this, we have two factors on the left, this, and we have two factors on the right. This is as if we had something like this, AB plus AC. This is the common factor, and it can be pulled out so that you have A times B plus C. Well, that's exactly what you have here. It's just a little more complicated looking. This is the common factor, and it can be pulled out. And you have M minus 4 times this plus this. So M plus 2 plus M plus 3. And then you just combine like terms. Here we have 2M plus 5. And we still have our M minus 4. So that's the final answer. Okay, in this problem we have three terms. Here's a term, here's a term, and here's a term. Each of these two terms have a couple of factors. So here's a factor, there's a factor. This is all one factor. Here's a factor, there's a factor. And if you notice, the common factor in each one of these terms is the 2 minus x. And here's a power of 3, here's a power of 4, here's a power of 1. So I can only take out a power of 1. So I'll take out my 2 minus x. And that's going to leave me with 5 and 2 minus x squared minus 2 minus x cubed plus 4. Okay, and then I can clean this up a little bit. Let's see, what can I do to clean this up? All right, so this is going to be 5 times, I'm going to square this. All right, this problem has three terms. This entire thing is a term separated by that minus. That entire thing is a term separated by that plus. That entire thing is a term. In each of these terms, I have a couple of, well, most of them have a couple of factors. That 5 is a factor. That's a factor. This is all a factor. This 4 is a factor, and that's a factor. So my common factor within each of these things is 2 minus x. Now, this has a power of 3, this has a power of 4, this has a power of 2. My smallest of those is a power of 2, so I can take out as much as a power of 2. And what that leaves behind is a 5 and a 2 minus x from the first term, minus a 2 minus x squared from the second one, plus 4 from the third one. And then I can clean this up a little bit. This is going to be 10 minus 5x if I distribute that, minus, I'm going to use the shortcut to square that binomial. So remember, when you square a binomial, it's the first item squared twice the product of the two items. The product of the two items is 2x, so twice that is 4x. And then the last item squared. Negative x quantity squared is a positive x squared. And then we have this plus 4. And we still have this 2 minus x squared. Okay, so now I'm going to take this negative and distribute it through. So here I have 10 minus 5x minus 4 plus 4x minus x squared plus 4. Okay, and finally, I'm going to combine like terms. I have 2 minus x squared, and let's see, I'll just do this in order. I'll put this first, that's negative x squared, and then I'll look at my x's. I have this and this as x's, and that becomes a negative x. And then my numbers, I have this 10, a negative 4, and a positive 4. That becomes a plus 10. The order technically doesn't matter. I could have written that in a different order, but that's my final answer. Okay, so there's an r common to everything, but instead of just pulling out an r, I'm going to pull out a negative r because I don't want my leading coefficient to be negative. So that's going to make this a positive r squared. This will make this a negative 3r, and this will make this a negative 5. And that's all you can do. Okay, so we have two terms here. There's 12 can go into both of them, but instead of pulling out just a 12, I'm going to pull out a negative 12 so that my leading coefficient is not negative. And then we have an s. Here's a 5 and a 4. 4 is smaller, so I'll pull that out. And it leaves me with s minus 4. And that's all I can do. Okay, so 2 can go into each of these, but instead of taking out just a 2, I'm going to take out a negative 2 so that my leading coefficient becomes positive. And then I have a x to the 5th, 3rd, and 2nd, so I can take out an x to the 2nd. I'm going to be left with x cubed minus 3x minus 2. And we're done. All right, when you have 4 terms, you're typically factoring by grouping. In the beginning, the book will give you easy problems that the order works. As they get more difficult, you may have to reorder the terms in order to make this work. But this is the basic idea. Pair off 2 of these things as if they're a separate problem. Okay? And factor the first 2 as if it was just a separate problem. So they both have an x. So I pull out an x, and I'm left with m plus 3q. Now, if we look at this, they both have a y. So I pull out a positive y. I need a sign there because it's not the first term. And it leaves behind an m plus 3q. Now, the way I have it written, I have 2 terms. This is all one term separated by a plus. That's all one term. This term has 2 factors. This is a factor. This is a factor. Factors are items used in multiplication. So if you notice, I have a common factor. My common factor is that entire m plus 3q. And so that comes out. And I'm left with the x plus the y. Just as if I had an x a plus y a, the a would be common, it would come out, and I would be left with x plus y. Well, this is like your a, that entire item. It's just a little more complicated looking, and that's called factoring by grouping. Okay, again, we're going to be factoring by grouping, so I'll just put these first two together like as a separate problem and those second two together. The first two, there's a 2 common, so I pull out the 2 and I'm left with 5m plus n. Now, once you put this, you have that there, you might as well just put it again, because if this is going to work, you're going to have a common factor. So you just put it there. Then think about what you need to put here so that if you were to distribute, you get back to that. And it looks like it must be a positive k. So now we can see that the 5m plus n is common. So you pull out the 5m plus n, and you're left with 2 plus k. Okay, when I look at these first two, I can see that I just have a 2 in common. So I pull out the 2, and I'm left with 2 minus q. And immediately I'm going to leave a big space, and I'm going to put 2 minus q again. Leave a big enough space that you can put a sign and a number in there. Then think about what you'd have to put here so that when you multiply, you get back to that. And it looks like a negative 3p. Double check that both terms work. Negative 3p times this is that. Negative 3p times negative q is a positive 3pq. So this works. My common factor is a 2 minus q. So I pull that out, and I'm left with 2 minus 3p. If you're not sure that this is done correctly, just take the time, especially on a test, to FOIL this and make sure that you get back to the original. Once you FOIL it, your terms may be a little bit out of order, but they should all be there with the correct signs. Okay, this is the first factoring by grouping problem that's a little bit more challenging. And the reason why is the way it's ordered won't work for you. There's nothing in common there. So we have to reorder this, and there's lots of ways to reorder this. There's just not just one way that's going to work. So don't spend too much time thinking about it. Just take your terms, start with your p squared, and either choose this one or this one. Either one is fine because they both have something in common. So let's say I chose this one, plus pq, and then I'll do minus 4zq minus 4pz. Now, I did this in a rush, and I may have put these backward, but it's okay. We'll see how that's going to work in just a moment. Okay, so the first two, it looks like there's a p in common. So I pull out the p, and I'm left with p plus q. Now, what I want to do is leave a big space and put p plus q down again immediately. Then I'm going to think about what goes here so that I multiply back and get to these things. And again, it might be out of order, but that's okay. In fact, it is out of order. There's nothing that I can multiply this by to get to this first term, but I can multiply to get to that second term. And it looks like I need to put a negative 4z. So when you check both terms, it does distribute, and I do get those two terms, albeit out of order, and that's okay. So now I can see that the p plus q is common, and I'm left with p minus 4z. Again, that's a little bit tricky, so especially on a test, take a moment to FOIL this and see that all four terms will come back to your original with the correct signs. Okay, this looks like it's going to work because we have stuff in common. So when I look at those two things, they both have a 7 in common and they both have a b in common. So I'll factor that out. I'm leaving behind an a plus 5c. So I'm going to leave a big space, and I'm going to put a plus 5c again immediately, because what I leave behind here, I have to leave behind here. Then I'll think about what I have to put here so that I multiply and get back to those. And it looks like a plus 1. So I'll just put a plus 1 there. Now my a plus 5c is common, and it leaves behind a 7b plus 1. Okay, the order of this problem also works. It looks like there's an m squared common to both of those, so I'll pull that out, and it's going to leave behind an m plus 4. So again, I'll leave a big space for a sign and a number, and I'll put down m plus 4 again, because what you leave behind here, you have to leave behind here. Then I'll think, what do I need to put here so that when I multiply, I get back to these? And it's a negative 6. And it works for both terms. So now the m plus 4 is common to both of those, so that comes out. And I'm left with m squared minus 6. Again, you can always FOIL to make sure that you get back to the original and that you have the correct answer. Okay, in this problem, I personally don't like that the leading coefficient is negative. I'd rather have it positive, so I'm going to reorder this. And these two things have stuff in common, so I can just leave it in like that. So I'm going to have 2a squared b plus 2b cubed, and I'll just put these ones down. Negative 3a cubed minus 3ab squared. Now when I look at these two, they both have a 2. They both have a b. So I'm going to pull out a 2b. And that leaves behind an a squared from the first term plus b squared from the second term. And I'll leave a big space, and I'll put a squared plus b squared down again. Then I'll think about what I have to put here so that when I multiply, I get back to these. And it looks like it's going to be a negative 3a. And double check that both of these terms work, and they do. So now I can see that I have an a squared plus b squared, that's common. And it leaves behind a 2b minus 3a. And again, if you're not confident, FOIL this and make sure you get back to the original, especially on a test. Okay, the order of this doesn't work because there's nothing in common there. So let's just start with the 4, and we'll pair either one of these two things. They both have a 2 in there. It doesn't matter which one. So let's say I say a negative 2y, and then now I'll put the plus xy, and then the negative 2x. And again, the order of these, I wasn't careful. They may be backward, but I don't really care. It's not going to cause me any problems. Okay, so when I look at these first two, a 2 is in common. So I pull out a 2, and I'm left with 2 minus y. And I'm going to leave a big space, and I'll put 2 minus y down again because I want to leave the same thing behind. Then I'll think about what I have to put here so that I multiply and I get back to these. And I see I did put them out of order. That's okay. To get to a positive xy, I need to multiply by a negative x. And when I multiply negative x times 2, I get negative 2x. That works. When I multiply negative x times negative y, I get a positive xy, and that works. So now I can see I have a 2 minus y common, and I'm leaving behind a 2 minus x. Now, if you were to check the answers in the back of the book, they may have showed something like this: y minus 2 times x minus 2. And this is also correct because this is the opposite of this, but this is the opposite of this. So for example, if I had 8 minus 3 times 5 minus 2, this is a 5 times 3, which is 15. If I did it the other way around, 3 minus 8 times 2 minus 5, this is negative 5, this is negative 3, and I get 15 out. So as long as if you flip both of them around a negative, you'll get an opposite for both of them, and then when you multiply, it comes back to where it should be. So this is fine. This would have been fine as well.